Chapter 12, Part A, Deflection of beams and shaft, Example 1, Solution 2. So in previous example number 1, we calculate maximum delta and also elastic curve equation based off a moment equation. This time we want to uh, calculate or determine the elastic curve, but this time directly from the load distribution. So let's see how that goes. Again, we have a two simple support beam uh, having a uniformly distributed load of W at the entire cross section. So if you remember last time we just learned that delta maximum for such beam and loading is 5 WL to the fourth and over 384 EI, and theta is a WL cubed over 24 EI. Let's so this is delta max, which is it should be goes by 5 WL. That's a 5 WL to the power of 4 over 384 EI, and theta is WL cubed over 24 EI. This time we want to calculate the same values, but this time from the load distribution function itself. So let's see how that goes. So if we want to determine the elastic curve from the load equation, so that's EI d to the power of force y over dx to the power of force is a negative w, and the negative is just the downward direction of w. So by a first derivation of by first integration of load, we can reach to shear. That means area under load is shear, and by each integration a new constant disappear. So that's a constant 1 if we call this equation 1. And by the second integration of load or integrating shear, we can reach to moment, and again the second constant also appears, C2. Mhm. If we call this equation 2, this is theta A and this is theta B, and they are identical to each other due to the symmetry of the structure. So in this method, because from load to uh, deflection, we have four consecutive integration. So load by area under load goes to shear, area under shear goes to a uh, moment, area under moment go to a slope, area under slope goes to delta. So by four consecutive integration, we can get from W the load to the elastic curve. So because we have four integration, we do have four integration constant. So by each integration constant, we need a boundary condition for that. So four integration constant goes by four a boundary condition like A, B, C, D, as you can see here. So like if we have equation 2, EI d squared y over dx squared equal to mx, and that's this equation, including two of the constants. So let's see how that goes. A and 2. So that's A, and 2 gives us a C2 is equal to 0. Uh-huh. C and 2 gives us C1 is a half of WL. So in that case, it just says this time C and 2, if you replace C in 2, which is equation of moment, give you C1 is equal to what? C1 is a half of WL. Let's move on and integrate the second equation to get the equation for slope. So by integrating, by replacing the numeric value of C1 in 2 and integrating moment, we can get the slope. And the third, a constant appears. So that's a C3. If we call this equation 3, and by the last integration from theta, we can get to elastic curve itself and force integration, force constant and force equation. So let's go to the boundary condition again to know how to handle to how to calculate the C3 and C4. So in equation of theta and equation of delta, mm, b and 4, this time b and 4. Mhm. So that's b. B says at x equal to 0, y is equal to 0. There is no uh, vertical movement because of the support. And and 4 is this equation. So if you replace all the x by 0, it just gives you C4 goes 0. Hmm? At the same time, if you replace, it just gives you C4 equal to 0. At the same time, if you uh, give the use D and 4 this time, then it just gives you C3 equal to a negative 1 over 24 WL cubed. So how that goes, it just, you can simply goes look at the D, and that says at x equal to L, y is still 0 because there is a support, no movement. So D, replace that in equation 4. It just simply gives you what C3 is. And that's numeric value for. So far we got all our constants. So that's C1, C2, C3, C4. We got all of them. So let's replace that in elastic curve equation to see how that goes. So that's the equation of elastic curve. Mhm. And if you replace x by L over 2, which is the center, because that's due to symmetry, that's the delta max, you can get the same numeric value for, again, that's a 5. That's a 5, a W L to the fourth over 384 EI. And theta A is equal to theta B, and that's WL cubed over 24 EI. Thank you.